labs. Awesome. Thank you. Thank you for that. Thank you for that. So let me turn on my camera. Oh, sorry. Share my screen. Okay, so please confirm via thumbs up if you can see my screen. Confirm for me if you can see my screen. Okay, thank you, Amy. Awesome, awesome. So we are going to start, and today, in this morning session, we are going to do 2 modules. And the modules that we're going to do in the morning session, one of them is managing processes, and the other one will be on managing services. Managing services. And then, let me see. So we will be doing managing Linux processes. That's what we are starting with right now. And then after this, we are going to do managing Linux services. And then in the afternoon, when we come back, we'll be doing Linux software management and managing Linux log files. Managing Linux log files. They are relatively short topics, and they just give you a good introduction to systems administration. Systems administration. And we're talking about systems, we're talking about the programs, and we're talking about the processes that you'll be dealing with, especially when you're trying to manage servers. Now, there are different job roles in the cloud, and there are even those roles that are coming up, or roles that you find combine different things. They are not strictly, as in strictly when we are talking about cloud roles, they are not really fit into one. You can't really say that this is a cloud engineer's role, or this is a DevOps role, or this is a software, a solutions architect role. Like there's a time that I interviewed for a job that needed a server engineer. You see, a server engineer. So being a server engineer, what it means that you are going to bring in multiple skills together. Because looking at the JD for that particular job, it required a number of things. One, it required familiarity with the Linux operating system, which is number 1. Number 2, it requires your understanding of security best practices, that is security. Number 3, it requires your understanding of the well-architected framework, that is solutions architecting. So we'll be talking about the well-architected framework later in this course, so that you understand when you're talking about what is well-architected framework, you will then understand when we get into that. And then another thing that it also required some good understanding of DevOps practices and DevOps tools. So DevOps practices and DevOps tools were also required as part of that particular job role. So even in the process of time, when you start looking at these job roles, when you start looking at these job descriptions, like I even saw another bank here in Kenya, a local bank, looking for a solutions architect in their title, but when you come into the job description, you get Linux is mentioned somewhere. You get DevOps tools is mentioned somewhere. You get security is mentioned somewhere. So some of these jobs, it might be the title of you in terms of your experience and your knowledge. Your experience and your knowledge. I hope this internet is okay. Okay, your experience and your knowledge. Anytime you lose me, please let me know. So that's where we are at. So this is what we'll be covering, and I just needed to mention that as we start. So we are going to start, and I already have my lab running because I'll be doing some demonstration for you guys. I have my EC2 instance running. So let me just restart that. Someone remind me in 20 minutes to start my lab again so that I don't get kicked out. Kindly do that. So my lab is ready. That is awesome. Good. So I've just said that today we are going to start with managing processes, and this is part of Linux fundamentals. And by the end of this particular module, you are supposed to have learned how to define a process in Linux, to describe basic commands for process management, and to compare the ART and cron commands for job scheduling. The ART and cron commands for job scheduling. So those are like the 3 main objectives for this particular module. So let's get started by defining what a process is in terms of Linux. And before even we look at processes, let us first of all look at what a program is. So you guys are using computers, either Linux, Mac OS, or Windows, and know that these machines that we have run based on what we call programs. So what is a program? A program is a series of instructions given to computers that tells which action the computer should take. So a program is a series of instructions. It can be a thread of instructions, instruction 1, 2, 3, 4, up to whichever number that tells a computer which actions the computer should take. So a computer without programs, it is just a box. It requires these programs because it is these programs that will now instruct it that you need to do A, B, C, D. And then you say that there are actually two kinds of programs. The first type of program is called a system program, and the other one is called application program. So what is the difference? So we are told that there are these two kinds of programs. One is system and another one is application. And these ones, these programs have these attributes. So one of the attributes is primal computer functions. For system programs specifically, they actually take care of the main computer functions, and they also include operating system commands, and it is often obstructed, as in you don't get to see these programs in action, as in tunasema they work on the back side of your computer, or on the inside of your computer, so you are not really able to see them running. And when you start running these commands, you now get to see those programs, some examples of those systems programs. Then utility programs are examples of system programs. An application, utility programs are an example of system programs. So that's about the system programs. Then when you start talking about application programs, they have these two attributes. One, comprehensive program that performs a specific function. And then two is it can be used by a user on another program. So examples of an application program, when you talk about application, short form for application is apps. When we talk about these apps, an example of it is a word processor, a database management system, or games. Or games. So an example of a word processor, someone tell me, what's an example of a word processor that you know of? An application that fits in the category of word processors. Give me an example. I'm waiting for your examples. MS Word, yes, MS Word is one. Notepad is another one. What were Linux? Represent. Niliona mko wengi. What word processor are you guys using? Watu wa Linux na watu wa macOS. Obsidian. Obsidian is a word processor. Interesting. WPS for Windows. For Android, sorry. LibreOffice Writer. Yeah, LibreOffice Writer. What were macOS? Do you have anyone from the Mac side of things? Word processors in Google Docs. Yeah, Google Docs. Word processors in what? Word processors in Mac OS. Let me just check for you guys if we have any interesting one. So anasema we have text edit, pages. Okay, LibreOffice, nimeona hiyo LibreOffice yenye mnasema. Awesome, Google Docs. So those ones have been mentioned. That one has been mentioned. That one has been mentioned. So awesome. So we go with those examples. So next is database management. Any applications you know that can be used for database management? Yeah, I'm giving you guys an opportunity to score those engagement marks. SQL, thank you, Habakkuk. SQL is an example for database management system. SQLite, nimeona SQLite imekuwa represented. Is there any other? MongoDB. NoSQL. Postgre. Good. Postgres. You've missed a G somewhere, Musembi. Unless there is one that inaitwa hivyo. MySQL. Awesome. Yeah, good. Awesome. Thank you for that. That's awesome. So, what about games? Give me examples of games that you know of. Hapa najua mtanipatia examples mingi. Let any examples of games. The games that you know of. FIFA, Minecraft, Candy Crush, Need for Speed, NFS, GTA. Alpha, nilijua utakosa kurepresent GTA. Awesome. Ladies, there are no examples of games that you know of or play at Game of Thrones. Is there a game called that? Unatupatia ile movie. I want to see an example from the ladies. Si lazima mkuwe mmecheza. Subway Surfers, good. Subway Surfers, okay. Temple Run is fun, by the way. Temple Run is fun. Ile kumezwa nako kakitu. Kwani wote mnacheza tu Temple Run peke yake? Ai, Sharon, peana any example ingine pia. Give other examples. Games are good. They are very good way of netwaje? Just resetting, refreshing. Hero Wars, awesome. Thank you for those examples. So that is awesome. So those are just examples of programs that now fall under application programs. There are two main differences that distinguish systems and application programs. A system program is a native computer function. It's a native computer function. An application program is added to the computer. Ile nasikia tunasema nimeinstall ka game, ama nimeinstall VLC, ama nimeinstall what else do we install? Nimeinstall ka game, nimeinstall VLC. Yeah, nimeinstall DJ. Ilikuwa inaitwa DJ what? That DJ thing. What is the name of that DJ application? I don't remember. DJ virtual DJ. You see, I knew it. Nilijua najua. Ndio hiyo. So those are some of the programs that we do install. So when you have your terminal running, or when you have your command line interface running, now how do you find a program? For example, how do you find a program? So I'm going to pull, give me a second. I'm going to pull, sorry for that. Yeah, I'm trying to click something here. I'm going to pull this terminal here. Okay, so we have this one running, and then I'm going to clear everything first. Clear. Okay, then we'll be running those instructions just as provided. We'll be running those instructions as provided. Here we come here and we run. Let me see, where is it? Here, let me make it a bit bigger for guys to see from where you are at. Save. Appearance. Change this. Let's make it just a bit bigger so that you can see from where you are at. Apply. Okay, so let us run this first command, echo, and then $, capital PATH, $path, echo $path. Okay, so let's see, enter. So when we run that, what we get as our output, as our output, it shows us the path to the program that is currently running, the active program that is currently running. You can see the directory home /EC2 users /local/bin, all of this till here. You see, so that's how you find a program. When a program command is run, the system looks in the specified path, such as the path variable for the program. So the path variable this is how you declare variables, especially when you are running stuff on your terminal. This is how you declare variables, by using the $sign and the capital of this. What for Windows, we do set path square environmental variables. Now it normally has that $sign, and then later on, when you guys get into starting to do mini programs, or rather mini projects or mini portfolio projects, you will discover that one of the things that you'll be doing a lot is setting environmental variables on our terminals. So if you're using VS Code or any other IDE, we'll be doing a lot of that. So we'll be using that $sign, and that $sign is very, very important when it comes to setting those environmental variables that we'll be using much later in this course. So when a command is run, the system searches this path for executable file for the program corresponding to the command. When the executable program is found, the system loads the file into memory schedules, running time for it on the processor, and assigns it a process ID number. I don't know if you guys have had a chance, maybe guys who are into software engineering, if you've had a chance, sometimes when you're using your terminal and then you are trying to run a program and then you run into an error, or you are trying to run a database, you're trying to run a program that has a database that is supposed to be running on a specific port, and then you get an error that tells you that that port is already in use. Now, one of the things that you do, there's a command that you run that first of all shows you all the process number, the process ID number. It shows you the process ID number, and then you will use that process ID number with the kill command to kill that process, so that now when you rerun it, there won't be a conflict. There won't be a conflict. So the process ID number that we're talking about is that particular number that you use, and we will see how to use how to read it in the next slide. So most process administration is done by using this PID. So process administration is a matter of checking which process is running, seeing if you can kill a process or stuff like that. So that's about the program. Now, when we talk about a process, what is a process? A process is a running program. You see, that's why we could not define a process before we got to understand what a program is. So a running program is what we call a process, and it is defined using a process ID number or the PID. It is viewed with multiple commands. Two main ones are PS and PS3, and we'll get to understand the difference between the two. So for instance, when I just run PS here, PS, small letters, enter as a command, you can see it is showing us the processes that are running in terms of, you see, we have the PID, we have the TTY, we have time, and we have the CMD. So all of this will be defined later. Just opportunity, we will define them. And then you can see under CMD, we have bash and we have PS. Bash and we have PS. And then, of course, we have the PID numbers, TTY, we have that shown, and then we have time shown here. Then we also have this command called PS3. Let me also run it. So it's single connected one, PS3. So when you run PS3 is different from PS. You see what PS does? PS gives you it gives you your output in like a tabular form. But PS3, it gives you the output in a tree format. And you know how trees look like. A tree has a trunk, and then from the trunk there's a trunk, and then there's a branch, main branches, and then there are those two sub branches. So you'll get that this trunk is what connects all the processes together, because the processes depend on each other, and then because this is the main connector, from it stems, from it we have these branches. The branches are now like the main processes, and then on each branch you can get sub branches. Those are what we call child processes. So the parent process is what is directly connected to our main trunk, and then on these sides what you see as branches, those branches are the processes, the main processes, and then from those main processes we now have some sub branches. Just think of it as a tree. Those sub branches are what we call child processes. You know, those are what we call child processes. So what you see connected to this main line here are all processes, and then connected to them are now child processes. So if you see these ones, there's that curly braces, those curly braces, these are what we call child processes. So Amazon-SSM-agent is actually a child process. Audit D is a child process. GSSP, GSS system-MD dash user work, this is a process. But now child processes, unaziangalia, they are in these curly braces. And then the number you see here, like this number 8, it tells you that there are 8 instances of those child processes running. You know, there are 8 instances of those child processes running. Then these 2 tells you that there are 2 instances of this main process, Ajeti, running. You know, 5 instances of this sub-process or this child process, GSS proxy running, you know, all that. So you would wonder, why are we talking about this process? And notice the importance of us even doing these commands here. They help you because debugging, for again, for guys who have done software development or engineering before, you'll understand that debugging is what occupies like almost 80% of what a normal dev does. You know, because when processes fail, you have to sit down and now start looking for where that error has happened. Like, for example, what happened yesterday with AWS. I believe the engineers were very busy debugging, trying to understand where has the problem come from. And, you know, you cannot just take, you know, it is just it's just many computers that you have in your servers, in your availability zones, in your regions. Now you're wondering, these things are down. How am I going to find the root cause of this problem? So by getting down into these commands, by getting down into the output of this command, some of them are logs, some of them are matrices, some of them are traces. By getting into them, then you will be able to read and say, but the problem is with this SSHD. SSHD is not running. So that's the problem. So if that is the problem, then you will have to run a command to restart that process so that it now runs, and then everything else can flow as expected. Everything else can flow as expected. I hope that one makes sense. I hope that one makes sense. So this notes, it's the same thing that I've just explained. Then now processes are normally in these states that you see here. Let me get this one out of the way first. I'll pull it back when we need it. So processes are normally in these phases that you see here, or in these states. So we can have a process at the start phase, or at the start state, at the ready state, running state, waiting state, or stop state. So the start state is the process. This is where the process is created. So if you want to run a process, like again, if we use the SSHD as the process that we want to run, we create it first. So there is normally a command that you use to create any process that you want to run, you know, and then once that program has been created, it moves on to the next phase, which is the ready state. And here it is waiting to be assigned. To be assigned what? To be assigned maybe memory, to be assigned RAM, memory mostly. And if it is a system that's going to consume things like CPU space, so that is also something that will be assigned to it. But as you just saw from what I shared in terms of the PS tree, you can see that there is one process, but that process is connected to other main processes and child processes. So sometimes a process that has already been started and is ready will go that process to start, because it cannot run to completion without these other processes. So it will go into the waiting phase, and then once that other process that it is waiting for starts and is ready, then it will combine, and then it will start running, doing what it is doing, because, you know, processes start and finish. After it has finished what it is supposed to do, it enters into a stopped state. So Gideon is asking, are the processes ending with D, like audit D, system D, not processes supporting other systems and processes? Let me see. So you're asking processes that are ending with D. Let me see that. Where is this? Where is this? Where is this? Just a sec. Just a second. So the likes of Akina System D, you've given us some good example. So let me get this. Where is it? So let me see. So where is that here? So you're asking things like audit D. Where is audit D? Let's see, where is audit D? We have this one also ending with a D. We have system D, we have SSHD, we have SMD. And then here we had, there's that audit that you've mentioned. That's what I was looking for, login D. So what I'm getting here, processes in Linux, sorry. The meaning of D is for daemon, a background service that runs without direct user interface. Yes. So, and examples are exactly as you've given. Like we have SSHD, Audit D. We are not seeing cron D here, but cron D is also mentioned. We have system D, and system D is very, very important because this one manages system startup, services, and dependencies. This is very, very important. Then SSHD, and why we see SSHD running here, even in our terminal, is because it actually handles incoming SSH connection. Remember, we are connected to our instance via SSHD. So yes, so the D, Gideon, you're right, the D stands for daemon, and it is a background. Good. Thank you, Gideon, for that. Thank you for that. So, so that is that. So that is that. Now, here, the various states have just been explained, where we say start, the process is created; running, the process is in progress; waiting, the process is waiting for an event or another process; then stopped, the process has finished running, imemaliza kazi yake. Now, I mentioned this one when I was talking about the tree, the PS tree, where we say a child process, there's something that we call a child process, and we say that some services and applications are complex and require more than one process to provide more functionality. These services spawn child processes, as in give birth to, yeah. So a child process can also be called a sub-process, and often child processes do inherit most of the attributes of the parent process. You know, every process that you have has got its own attributes. So when a child process is spawned out of a parent process, then that child process will most definitely inherit what we call the attributes of the parent, the attribute of the parent. So all that introduction was bringing us to this nice subtopic here, where we are going to talk about the basic commands for process management. So there are some very good commands, and one of the commands that we've already seen in action is the PS command, and that's a good place to start. So let me clear this and just run the PS command. One sec. There goes. So when you run PS, enter, you see what we are getting? We are getting an output with the PID, TTY, time, and CMD. We have a PID number for both of these two. And then we have time. And then we have the CMD. We are told that PS displays current processes in your operating system. And PS in full is process status. PS stands for process status. And this command gives an overview of the current processes that will be running in your operating system. You know, you understand? Internet. So it gives the commands that will be running in your operating system. Within this overview, it displays information on active processes that include the following. You remember the PID we saw? That PID is process ID in full. So every process has got its own unique ID. Then TTY is terminal type that the user is using at the moment. Terminal type, TTY. Then we have something that we call time time. So time shows the time that the process has been running. For how long has the process been running? And then CMD is command. So for command, what command does, this is the name of the command that launched the process. So what did you run for you to run that process? Like you saw, we ran a command called PS for us to get an output that we have. So when you come back to this example and we just look at those, so our process ID, PID, NISI 1715 and 3598. Then our terminal type, here it is, you see, just written like that. And then for the time that this has been running, this is what it shows because we've just started this process. And then for CMD, the command, the command that launched the command that launched the process. So this is what launched this this whole terminal to run, and then PS is what we have run in order to get this. PS is what we have run to get this. Let me try and do. Let me try and do one more command. Like which one? Yes, I don't know if it will pick this one. My terminal is hanging badly. Enter. Let's see, pwd, enter. These are commands that you guys already know. Then let us run ps, enter. I'm not very sure if it will pick those ones. It hasn't, because these ones, these two are not actually, they're not going they're not interacting directly with the kernel. They're not interacting directly with what we call, not really kernel, but what we call systems applications. These ones are supposed to be looking at, okay, this is specific. This one is just asking a question of where am I at the moment? On which path am I working at the moment? But now LS is supposed to look at the processes that are running and the processes that myself I have started and they are running. So even if you run it by itself, you can see it's not giving us any output because you don't have, not processes, sorry. The files, the folders that I have in that path. So I don't have any file, I don't have any folder. So it is just asking a question. So these are not commands that will directly interact the same way we see the likes of Kinabash interacting with the system application. But at least the PS command, you have just seen what the PS command does, and we've been told here that this one, it gives an overview of current processes that will be running in the operating system at that level of the OS. At that level of the OS, where has my Nini gone? This one. At that level of the OS. So PS has a number of options that you can use. You can use it with you can use it as PS-EF and then pipe. Remember this straight line that we told you about? That is a pipe command. So the pipe grep SSHD. You use grep option to filter an exact process. And in this example, we are trying to find SSHD process in the PS output. If you have multiple running processes, which can be pages long, yeah, again, system administration, when you're running a server, hata kama ni server yako tu with your own small processes or your small workloads, what you'll do, you'll have so many commands. So maybe there's a specific command that you're looking for. So you can use this command to get it. This command to get it, let me see, where is that? EF explain. Don't use any option, display processes. EF list. Yeah. List all current processes. So if we do this, for example, if we do this command, let us see what we will get as our output, and then maybe move it from there. It will go to is this one visible? No, just a sec. I want to let's clear our screen again. Sawa. Then after we've cleared our screen, let us run PS space dash EF, and then we pipe it, do grep, then SSHD. When you do that and enter, this is what you will get as your output. You see SSHD has been marked. Someone remind me on the chat. Someone remind me on the chat. You've met grep before. What did you tell you that grep is used for? The grep command, what is it used for? Grep command, what is it used for? Someone tell us, grep. This is not the first time that you're meeting grep. What is it used for? Someone wants to tell us, kuongea? Yeah, it's used to search. Checks and marks the specified string. Yes, it checks and marks. So yes. And for those who are interested to know what grep is in full, it is global regular expression print. Global regular expression print. And yes, just as Habakkuk and Gideon have told us, and then it marks it. You know, it highlights it the way you can see here. The way you can see here. So you can see SSHD, because we are trying to check it. So, yes. So we have filtered all the processes, and now we are left with our SSHD because this is what we are looking for, and that is what we are able to. That's what we are able to see. And let me see if I can make this one bigger and see kama itajeka kwa treble. So kwa root, we have that one running. Kwa root, we have another same SSHD running. Then kwa EC2 user, this is another path. We have our PID. Remember, these are our PIDs. These numbers here are PIDs. And then we have the same SSHD running, you see. And then it has been marked so that you get to see it with ease. So maybe this becomes important if during your investigations, maybe your system is slow, your system is not running, during your investigation, maybe you suspect, one of the devs or one of the guys in your team are telling you that, hey, I'm not able to SSH to the server. But when you look at everything else, the dashboard, everything else looks like it is running okay. Now, the problem might be down to the system's applications. So the systems program, the systems programs. So you come down and ask yourself, which system program is tasked with giving permission for SSH. Then you remember it is SSHD. Then you come and do a grep to check if your SSHD, it is running, if it's running. And if it's not running, you'll get a way to restart it so that your devs and everybody else will be able to access the system. So that's the important bit. So these other options, you'll try and run them. I've already run them and they're running okay without any problem. So everything that we're talking about in terms of commands. Remember, when we introduced Linux the other day, we talked about Linux and we said that how do I put it? The syntax for a Linux command, for a full Linux command, it has the main command, it has an option, and it has an argument. There are those three things. That's the anatomy of a Linux command. So the first thing that it has is the command, and then it comes with an option. So options here, we're talking about -E, -A, -R, -EF, -FPL, all of those are options. And then there's an argument. So an argument, like in the example that you've just seen, is SSHD. So SSHD is our argument because you are trying to find that specific, that particular process. We are trying to find that particular process. We are trying to search it. And of course, the command there was grep. You understand? The command there was grep. So that is for PS. That's for PS. Then there's another important command called PIDOF. PIDOF. So this command displays process ID of a running program. So don't confuse these two. Remember what we said PS does. Let me go back to it. This one gives an overview of current processes that will be running. Current processes, not a single process, but all the processes. This is process status. So it gives the current processes that will be running in your operating system. But now when you come down to PIDOF, this one displays the PID of a running command, that process ID. Maybe now you want to get the process ID, and I told you one of the reasons why we look for a process ID is maybe we want to kill that system, or not system. We want to kill that program and then restart it. No, restart it, because maybe it's causing some conflict, or maybe it is causing some error in the entirety of your program. So you kill that one first, and then you restart it, and then maybe it resolves that problem. Ni kama tu ile shida tu ya kitambo. You call customer care, unawaambia I have a problem, simu yangu is not doing ABCD. They tell you do this, toa battery, zima, rudisha battery, washa, try again. You see, stuff like that. So huku kwa nini kwa cloud things like PDOF will give us the PID. Once you have the PID, then you can run a command, something like a kill command, to kill that system. No, to kill that program, sorry, to kill that program, and then now you can restart it, and then things will be running. Okay, let us try out PDOF SSHD and see what we get. PDOF SSHD and see what we get. Clear that. PDOF SSHD. Let's see what we get. So you see, we have our PIDs. You see, all these three are actually PIDs for SSHD. And why do we have three? We have three because when we ran the initial command to search for SSHD, we saw that there were three instances of this that were running. That's why we have these three different PIDs. Now, to get it even better, again, I've just explained the whole of this, but now the following are commands that you can use with PDOF. So if you want to return only one PID, you use an option -s. You see, -s. So you come here. Let's see, PDOF. Remember, PDOF is our command. PDOF is our command. Our option is -s, and our argument is SSHD. You get that? Then when you run this, see what we get. So we are only going to get one PID, 1714, similar to what we have here, 1714. You see, 1714. So that is all. That's when you only want to return one PID. And then -c returns only PIDs that are in the same root directory. You know, that are in the same root directory. So let us try that one. PDOF. F kweli. Just a second. My terminal is hanging. Okay. PDOF -c, I believe, SSHD. Let's see what we are getting here. Give it a second. There you go. You see, so what this one is telling you, you see the answer we have here is the same. The output we have here is the same as this output here. So all of this SSHD, all the three instances are actually running at the root. They are running at the root of the server. So these other ones, you'll try them out when you are revising your notes. You'll try them out. And then, of course, we talked about the PS tree, and then we said that when a command is run, this displays the current running processes in a tree format. So remember, I talked about that main trunk, and then I talked about the branches and the sub branches. That is what has been explained here. And I told you that when you see these brackets, this one shows the processes, and then these curly brackets are what shows the child processes. You remember? So I hope you remember that. And these notes are just things that you will read just to cement what we've been discussing. Like I told you, if you see 8 asterisk in front of this, for example, it indicates that there are 8 instances of Amazon-SSM-agent processes running. Just that, there's nothing complicated there. Then, of course, with PS tree, there are also options that you can run with them, like -a, which shows arguments in the command line within the output, -p, which shows the PID, and then -c, which expands identical subtrees, and -n, which sorts by the same parent PID instead of process them. So an interesting thing here is that if you so choose to pursue system administration as a path, as a career path, as something that you want to really get good at, there is a very good, not just one, but there are very many courses, Linux. Like I remember we showed you in our previous classes, we showed you that there are courses offered by the Linux Foundation, just touching on Linux. You see, just touching on Linux. So you can get deep and get to understand all of these commands, all of their options, the arguments that they go with, and then you will be so good at Linux. And then now you become, like, for example, a Linux systems administrator. A Linux systems administrator. So there is such a job role. Then, as we continue with our commands, there's a command called the top command. So this top command displays a real-time summary of system performance and utilization and lists the processes and threads in the active system. No. So this top command displays real-time summary of system performance, which is very important, and utilization, and it lists the processes and threads in the system that are active in the system. Let us do an example here with the top command. Let me just make this one full. 1 second. Top. So when it shows you all this, we have all of this information here that is running. You see, it shows you how much memory it's consuming. It is showing you the CPU consumption. It's showing you all of these other many things, including our PID and who the user is. You can see router. There was EC2 user somewhere, but here you see it's root. Then the PIDs, you see all that. So you see all of that. What has Musembi shared? Watch I load. Let it finish loading. Good. Let me see. It's good to see that you are following Musembi. Awesome. There it goes. Look at that. PID, user, PR, NI, VIT, REST, SH. So if you want to know what those ones mean, that's your homework. Go and check them out. Get to understand what VAT stands for, what REST stands for. But the important, what top does, what it gives you that high level overview. Is it consuming? For how long has it been running? And who is the user using that particular process? You know, those are like the main things that you will need to see at any given time when you're using grep, when you're using, no, not grep, when you're using top, sorry, when you're using top. And then to kill this process, were we using Q or Control C? Let me see which one has worked. Let me see, Control C. Control C is supposed to kill the process. Yeah, it has killed it. So we are back to our prompt. So you can see here tasks, 99 tasks are running. Okay, we have 99, we have a total of 99 tasks, sorry. 1 is running, 98 are sleeping, 0 is stopped, and 0 is zombie. You will see the meaning of that in the next slide. Then CPU, we have 0.0 US, 0.0 sys, 0.0 NI, 100.0 ID, you know, all of the have this as our total. This is free. This is what is used. This is that. So if your system is running slow, and you have run all of this command, and now you are seeing all of these processes running, then you discover that, well, there are some of these processes, I don't need them. They are consuming my CPU for no reason, or my memory for no reason. What could I do? I want to kill them. I have the PID. I'll use the PID with a kill command, and I'll be able to kill that process. And then I will, you know, when you kill a process, the memory that it was that was using is now released. You know, it is released so that it can now be used elsewhere. You know, it can now be used elsewhere. So that's just something that a systems admin will do. That's what a system admin will do. Let me reserve this as is, near to this other monitor, and then come here. And then you say the top command displays real-time system summary and information of a running system. It displays information and a list of processes or threads being managed, just as we have seen. And then there are some common options that you can run with your top command, right, like -H or -V, which displays usage and version information, -B, which starts stop in batch mode. it starts stop in, we call it options that you can try out, I tried this -b. I don't know why my terminal refused to start it at batch mode, but basically that's what they are saying. Now I promise to explain that will, and this is what we are talking about. It shows you the number. Then we have the number that is running, and you're told the process is running on CPU or present in the run queue. This is the process that is running on the CPU or it is present in the run queue. Then these 98 that are sleeping, these are processes that are waiting for an input or output of a process. We say that a process has a start, it has a running, and it has an end. But hapa kwa running, it can waiting for another process so that it can now continue to the running phase and then to the finish state. So sleep here, the process is waiting for an input or output operation to complete and then stopped. When you talk about stopped, we say the process has been stopped by a job control signal or is being traced. And then, of course, we have zombie. So the process is a child process whose parent process has been ended. So it's a child process whose parent process has been ended. So sometimes it's possible to get a child process that is still running, yet the parent process has been terminated, because sometimes a parent is terminated and then the child process will be terminated next. I forget that strict hierarchy that the child process has to be terminated before the parent process. So when you get that child process that is still running when the parent process has been terminated, we call that one. We say that one is in a zombie state. So those are just good lingos that you can use. Those are good lingos that you can use as a sysadmin when you are talking where sysadmins are. Then we have this CPU metrics that you see here, like US value, time spent running the process in user space, that is 00 in the user space. Then sys value, time spent running kernel space processes. It shows you here. Then idle time, that's what we have as ID. Then WA is time waiting for input or output to complete. Then we have SI value, time handling software problems. You see, they've also made provision for that. Then, of course, ST is time lost waiting for CPU processes to complete. So here we had everything running at 0000. Everything was running at 0000. But now, from this Nini that they've given us here, from this screenshot that they've given us here, they're saying we had like 0.2 for user, 0.2 for system, 0.0 for NI. NI tumembo nini? NI, is it NI? Oh no, HI, sorry, HI. Time handling hardware problems. Then we have this NI. NI has not been defined because of why. Okay, just keep it. But we have our idle time and we have our time handling software problems. So all of that is important, because again, it depends on the processes that you are running. It depends with the complexity of the system or the number of users that you are using in a given system. The importance of a system is determined by the end users of that system. That system in itself is structure. So you see, when it failed, so many other applications that are hosted in the cloud actually faced serious problems. The likes of, in fact, yesterday, even Zoom had problems, because Zoom is also hosted on AWS. Zoom had problems. That's one. There's an app called Duolingo. It had a problem. I think there's a link I shared with you guys, just capturing the story, capturing the account from the different application users, what they were saying about their applications and the downtimes that they were facing. So imagine you've been given this job as a systems administrator, and I'm not going to use an example that is out of this place. So let us use a simple example of a place like Jumia. So you have been hired as a systems administrator operator working for Jumia, you know, Jumia, the system crashes. So things that you'll be running are these commands that you see here. You'll be trying to check, you'll be trying to troubleshoot, asking yourself, what is the problem? What is happening? Why are the systems down? Then once you have found the bug or the cause of the problem, you resolve it, and then the systems will be back. You see, the systems will be back up of what assist admin does, and it's actually part of what we do, both the right command to use. Good thing is that these commands are actually properly documented. Linux has a very good manual that shows you the various commands that you can use to achieve different ends that you're trying to achieve. So I hope that one makes sense. Back to our notes. So we've talked about the ST value, so memory space, swap space, RAM usage. So those ones are just things that you just read through. You're in Ashida. And you've heard me talk about the kill command. I've used it several times, and it's a very, very important command. So what the kill command does, so when this command is run, it explicitly ends processes usually when the process fails to quit on its own. If a parent process is ended, it usually also ends the child process. Remember, we talked about the zombie? So when you end a parent process, there's a possibility that the child process might still be running. So if you run the PID and find the PID of that child process that has refused to end, you can now force end it, or you can kill it. That's what we call kill, the kill command, the kill command. So the first thing that you need to know before you use the kill command is you need to know the PID, the process ID number, the process ID number. So we are given some note here. Tunaambiwa frequently used kill commands include the following: -9 sig kill, SIG kill, all capital, immediately stops the process with no graceful exit. Again, devs and people who have interacted with terminals. What does it mean to have a graceful exit? What does that mean? Then -15, niambieni hapo kwa chat. Then negative, or not really negative, -15, sig term, exits without immediately terminating. Sig term. Then -19 or -19 sig stop pauses the process and can use the command line. It pauses the process and can use the command line. So you see here, like for example, we've used -9, kill -9, then we have the PID. So what will this do? It will immediately stop. Kuna mwenye anajua graceful exit ni nini? Wacha tuiangalie tujue ni nini. Graceful exit. Give it a second. So this is the kill command, and kill command, you can use the kill command together with the PID. That's very important. And you guys, you'll start using this. You start using these commands very, very soon. Very, very soon. My comp is hanging, so let me try and search for what I'm searching using the mobile and see graceful exit in Linux. Let's see if this one will give me Yeah, listen to this. So what I'm seeing here, they're saying that in Linux, a graceful exit means ending a process or session cleanly, allowing it to release resources and close files. Okay, release resources, close files, and save data before terminating. This is actually what I was thinking. This is what I was thinking when I saw that word for the first time. So I was thinking the same way. Unaona, when you are using Windows, what are Windows? Mekumbukwa hapa. When you're using Windows, you can either finya there's this button that you use kuwasha machine. You can finya it kuzima machine yako. That's not a graceful exit. The graceful exit ni if I'm on this window with these programs, or let's say I have this main program running here as my browser, I end every program one by one. All working on a Word document, and I ended it. When I ended it, it asked me if I wanted to save. I said yes, it has saved it. If there was a download that was happening, I've waited for that download to finish. If there was any process that was running, I've ended all of those processes. Then at the end of it all, I come down here. Where I want to demonstrate. Let's see. I'm still not seeing my Nini. Give me a sec. I have very many windows opened here. Yeah, here. So I come here and then I say, I go to the option to shut down my machine. You see, to shut down my machine. Stuffing up. Yeah. Shut down my machine. So that is what we call what graceful exit means here is in Linux, a graceful exit means ending a process, close files, and save data before terminating. So let's see if this one will show me what I want to demonstrate. Inakwanga wapi? Not that. Where is it? Just a sec. Let me try and find it. Alt Control Delete. No, if I Alt Control Delete, you'll not be machine, but that's okay. That's okay. That's not very important at the moment. But I hope you guys have understood that short definition of what a graceful exit is. One sec. Then you. Okay. You. Just a second. Okay. Yeah, guys, that's what I was looking for. Yeah, we are back. So then we have these other commands that, okay, personally, I haven't really used them that much, but they're there. So the range is between -20 for highest priority to 19 for the lowest priority. So you can do nice option CMD, for example, or a nice option CMD. So for the nice one, this command adjusts the priority of a process that is already running. So renice adjust the priority. So priority inamaanisha the order in which it is allocated resources, for example. You know, so processes with the highest priority, when you're looking at your terminal, ukiona kuna yenye kona ka -20, just know that that one has the highest priority, and then 19 has the lowest. That is 19 without. So let us do an example command adjust priority. So let us see. Let me look at my terminal and see. Na mtu hajanikumbusha, I need to restart my lab. Wow. Start lab. I'm so lucky nimekumbuka. Na nilikuwa going for a break in a few, so nisichoke sana. Ni vizuri kuamka kustretch. These things can be something. One sec. So There goes. So we are looking at, so we want to look the NI that find that I nice, -20, you can see, -20, -20, -20, -20. So that is for, that is for NI. That is for NI. Not the whole video process. We'll look at it later. Someone is asking me something about class, about a previous video. So we'll look at that one later. So NI is for nice, and renice. Renice, you've heard what renice does. It adjusts the priority of a process. Maybe that process had been given a higher priority, but now you want to make sure you've discovered that it's not that important. You want to give it a lower priority. So you can use the renice command. You can use the renice command. So that is that. Each instance code on the system is referred to as a process. So is my internet, something is happening to my internet. Just a second. Let me close something here. Sorry for that. Where is that? I hope the internet is still on. Good. So jobs command. So we are told jobs are processes that users start and manage. Are processes that users start and manage that are identified by a job number. So these are processes that are identified by a job number, and they are started and managed by the user. So these are not the ones that tunasema ati za system za system. They are not system processes. These are processes that are run and managed by the user. So the jobs command will list the job processes number with the following syntax. For instance, in the background, or FG with the job process number or name to run in the foreground. So BG here, what BG does, BG ensures that that job process, that job process, or that job, if you want to run in the foreground, you can also bring it to the foreground by using the FG. So you use jobs command to manage these processes. Let's see. Let's see. Let me try and see. I'm not sure if we'll get an, because I don't have any process that's, oh, here it is. Where is this? Oh, here it is. So we clear this. Let's run the job command and see what we get. None found. Yes. Where is it? Here it is. So we will not. Yeah. So that's what the jobs does. Jobs run in the foreground until they are completed. When you have a job running in your foreground, it will consume shell. It will consume shell until they are completed. Then you can move jobs to the background. Remember, we talked about FG. So if you want to move a job to the background, you do FG, and then you use the how do you call that one? Percentage and then the job number. So that just move on to art and cron because this was part of our objective for the course. So let's look at this. We are almost done. So art and cron with options, they are also used to do specific things in the Linux terminal. So this command runs a task once at a specified time. The art, this command is used for one-time tasks. For example, running a backup script at 4 p.m. today only. Now, when you will be doing things that we call server maintenance or server management, sometimes the role of maybe updating that server falls on you. It's part of your JD. Now, instead of you having to wake up every day in the morning at 4 a.m. to update that server, or you want this server to be running or rather to be updated every first day of the month. You want it to be updated every first day of the month. Instead of you having to do this mundane task manually by yourself every time, you can actually run a script. And we'll be talking about scripts tomorrow when Joy will be taking us through bash scripts, and you will see how powerful scripts are. So you can write a script and then you program your system and tell them that tell it that there is this script that I have on this path. I want this script to run every first day of the month at this time, so it will be able to do that. So an example here, you can see here we have this we have this command that says at 1600 this run this script, demo-script.sh. So this is an example of a bash script. So bash scripts zinakwanga na .sh at a particular time, at that specified time. Oh, let me try agency. Please tell me if I'm still audible. Tell me if I'm still audible. Audible. Joy, am I audible?
Yes, you are.
Okay. Yeah, a challenge with these online classes. Kuna vile unaweza kuwa unajiongelesha na ujui. Thank you for that, Joy. Sorry. I was lagging. I'm sorry for that. When we come back from the break, I'll have changed my internet. Sorry about that. So, we are now looking at an alternative to the add command, and now we are looking at the cron command. This cron, I've used it severally, and you'll hear people talk about cron jobs, cron tab, and stuff like that. So this command runs a task on a regular basis at a specified time. So remember the art command, we are using the art command to run a task once at a specified time. That's the difference. Art, we use it to run a task once at a specified time. Then cron is used to run a task on a regular basis at a specified time. So if it is a one-off task, use what? Use the art command. Like let's say, for example, you just want to run a script once and you are done. Use the art command. But if it is something that you want to do, let's say monthly, weekly, yearly, hourly, if that is what you want to do, you can actually still write the same script, but now you use the cron command to make sure that now the script that you are running is able to run accordingly. So that's the difference between the two, and you will see a lot of it here. Like you see, for example, we have cron daily. So this is a process that will be running daily. Hourly will run hourly, monthly will run monthly, weekly will run weekly. And when you'll be doing these scripts, you'll discover that there is actually a way that you can bake this in. You can bake this in your script. You know, you can bake this in your script so that when that script runs, it sets that, and then now it is able to do what it needs to be done. Then we have the cron tab command. Cron tab command, we've talked about cron. So cron tab -a file name. This one creates a cron tab file that holds the commands and steps that the cron daemon will run. Remember, we've talked about this cron. So you want to create a file that will have all your cron tasks or your cron jobs. So all of those, they'll be run there. So it can also be used to list, modify, or delete a cron tab file. You can also use the same command here, cron tab, to delete or modify or list the cron tab file. Look at that. The cron tab file format has 6 fields, which stands for the following. So we have minute, hour, day of the month, day of the week, and the command. You know, so min, which stands for minutes, can take any value of between 0 to 59. Hour, which is still hour, can take any value between 0 to 23. You know, we have 24 hours. Day of the month, it takes the dates of the month, which can be anything between 1 to 31. Then the month can take any value between 1 to 12 for the 12 months. Day of the week, 0 to 6, because we have 7 days in the week. Then we have the command, any command or path. Any command or path. Then this not just goes to explain the same things. It goes to explain the same things. And then, of course, like any other command, cron tab can also have options like cron tab -e. This is used to edit cron tab file as the root user. Cron tab -l. This is used to view the list. So remember, we said you can use cron tab also to edit and to list. So those are some of the options that you can use, and that has been explained up to vizuri. And then, yeah, it has been a mouthful, but basically that is all about managing processes in Linux. Managing processes in Linux. I hope you guys have got at least a thing. I know it's a lot, and I know it might be new to most of you, but it is still important, especially when it comes to system administration. So I want us to look at these checkpoint questions, and then we look at the checkpoint questions. We look at the checkpoint questions just to see if someone has understood something. So, question: why might you need to stop a process? Why might you need to stop a process? Somebody? Why might you need to stop a process? Let's try answer them. Yeah, to free resources. That's awesome. Who answered that?
Musembi.
Musembi. Awesome. Thank you, Dan. That was awesome. Then, why is PS -ef pipe grep process name useful? Why is this command useful? I've talked about it. I've even demonstrated it. Why is it useful? Why is it useful? Why is it useful? I even used SSHD and gave you an example of a dev communicating to you as the systems admin, telling you that they are unable to SSH. Then you in your troubleshooting, you want to check if SSHD is running. So this command is used by an administrator to verify whether a program or a process or an application is running. You understand? That is why it is used. That's why it is used. Finally, the last checkpoint question: what is the difference between the @ and cron commands? This one you should answer. This one was easy. Nimwambia tu saizi. What is the difference between the @ and the cron commands?
The @ command is used for one-time tasks, and the cron command is used for tasks that are run on a regular basis.
Awesome. Who answered that? Sikuona.
Gail.
Who is that?
Gail. Patrick, it's
Sorry.
been GAIL.
Oh, awesome. Thank you. Awesome. Thank you so much. Now, yeah, the add command is used to run a single task. The cron command is used to run repeated tasks. That is awesome. Someone read for us these key takeaways.
Okay, the Linux systems run daemon services and programs. You can use the PS and PS trees commands to display running processes. You can use the top command to examine the process that run on a server and to examine resource utilization. You can use the at and cron commands to schedule when a command is run.
Awesome. Thank you so much. So that is all we have to cover on the Linux fundamentals, specifically talking about managing processes. But now remember, what we are telling you here is that this is just an introduction. There is so much that you can do concerning this. There is just so much that you can do. So if this is a path that you'd like to follow, also always feel so free to talk to us, and we can point you to the right direction in terms of additional resources that you can use even to deepen your understanding of Linux. And managing processes is one of those things that you might have to, that you will have to also get to. It's a very important skill to master. So that was managing processes. Now let me just see how the lab looks like. I think I opened it somewhere. Do I have it running? Okay, I think this is the lab. Managing processes. So this is the lab. Let us see how it looks like or what it is asking you to do. So the objectives of this lab is to create a new log file for process listing, is to use the top command and establish a repetitive task that runs your previous auditing command once a day. So you see, once a day. Now I have a question. Establish a repetitive task that runs your previous auditing commands once a day. So which command will you use here?
Cron.
Sorry? Cron or at?
Cron.
Cron. Good. Awesome. So remember again, in this lab environment, access to AWS services and service actions might be restricted to the ones that are needed to complete the lab instruction. So that's okay. All this we've been doing over and over. You know the process. Start lab. Once you've started lab and it's running, then you do click on AWS and then it will open the console for you. Then Kamakawa, step number 1 is normally to SSH so that you connect to the line, to the instance. And if you guys remember what you said about that instance, you create an instance because the instance that has been provided for us has a faulty key. So you create your own instance depending on whether you're using Windows or Mac OS or Linux. That is direct. Then creating a list, you just need to follow. Remember, you are told here, validate that you are in their home EC2 company A folder. And what command will you use? Present working directory. Then view all the processes that are running, and you've been given a command to run here. You have been given a command to run, and then you press enter. So it's just a matter of you following the instructions as they are, and then validate your work by typing cat. Okay. Oh, thank you, Msembi. Thank you. Ngoja kwanza. So, yes. Yes. So, what we will need to do. Thank you, Msembi, for that. Yeah, thank you. When you are given that instance, the faulty one, they've already created company A as a directory. They've also created the process.csv as a folder. As a folder. I believe that's what is meant there. So if you try to run a command and find that something does not exist, we will need to create it. We will need to create it. So let us just go through it. Nione kama kuna kitu ingine kama hiyo. We'll need to create it. Then of course we will be running the top command. You know what the top command does? We talked about it. You'll see what the draw command does. And then, yeah, everything, top command and its option. Then you'll create a cron job. So this cron job, company A is still important. So we will need to have this folder created kwa this directory. Inafaa ikuwe created hapo. So let's just see. Then lab complete. Okay. So let me try something before I release you guys to go for break. So let's try running present working directory and see where we are at. That's where we are at. So let us make directory company A. Okay. Then when we ls, that's where we are. Then we cd into company A. There, that's where we are. Then we touch. Let us touch and create this CSV file that they're talking about here. Where is it? Where is it? Process. But inafaa kuwa kwa shared folder. Just a second before I do that. Let me just do cd, sorry, dot. And then we do, what do we do? We do cut. No. One sec. Let me just copy this as is. I want to see the error that I'll get. If I run this, then I'll know what we need to do. Oops. Nijikopi mara mbili. Siende sana. Okay. One, two. Okay. So that is good, I believe. Let's enter. Oh, there it is. We have a problem. I've seen an error somewhere. Let's make this one bigger. Let's see. This is what we have run. No such file or directory. Shared folder. Shared folders. Give me a second. No, not that. That's not what I wanted. Let me see. Because the lab has to be done anyway. So we have to find a way. You ran this, you got that. Okay, let's try this. There's a command that they're giving me. Clear that first. Let's try running this command, make directory -p. Oh, hanging. So make directory -p. Okay. Make directory -p shared folders, and shared folders is capital S, capital F. This is the challenge you'll have. We have to create a few things that were already created for us. But I hope in the next unit, the nini yenye tutakuwa tumepewa itakuwa na shida. Okay. Shared folders. Okay. Then let us try and run this command again. Control C. That one. Let's see what we get. Now we don't have the error because we have the folder. Good. So that's what we will do. So that is what we will do. I'll give you the instructions, don't worry. I'll give you the instruction. Ndio mkifika hapo kwa lab msikwame. And then of course, you can, so natupatia answer. You can come and run your top command. You see what it's showing you? 100 tasks running, 100 tasks in total, 1 running, 99 stopped, blah, blah, blah. Then observe, blah, blah, blah. So you'll see everything. Then you'll come and create your cron job. So this one, I'm not doing it for you. This one, you'll do it, and then you'll have completed the lab. You'll have completed the lab. I just need to make sure that everything that you need to do the lab you have. So pale kwa group, kwa the main group, I will maybe during this break, ama during the lunch break, I will give you the additional instructions on how to go about this lab. So let me just write down the lab title so that I remember. I'll be working on it. Niwaambie ndio mtafanya. Managing processes. Sawa. So that is what we will do. That's what we will do. And then finally pia kabisa. Let me see. Let me see something here on. I don't think that this is a very hard one. I think you guys are able to do it. But mtu akikwama mahali, always feel free to ask us or even ask your peers in the group. I'm talking about the KC. So we told you that from this week, you guys will be doing your own KCs. But of course, we are here to guide you in case you have attempted your KCs, alafu ukashindwa kupata the scores that you want. Always aim for 80% or higher. Okay? Aim for 80% or higher. But if you need us to help you, just let us know. Just let us know. 10:30 imefika. Let me see. It's 10:33. This is the time we're supposed to be taking a break. Just give it a sec. Let me see. I want to make sure that the cases are running. Yeah. 05 questions. Awesome. Yes. Good. So cases are running. Sometimes pale KC haifanyi, KC inafanya. So you'll do the cases, please, cases and labs, and I will give you the additional instructions for your labs pale kwa the main group, our main group, and tuko both the 2 cohorts. So do take a break. Let us meet here at 11 sharp. 11 sharp. Let us come back at 11 sharp so that we do our next topic. Sawa, see you. Okay, guys. I guess we are back. Kama tumerudi, let me see by show of hand. Please raise your hand if you're back. If you're back, please raise your hand. Thank you for those hands. Keep raising them and keep them raised. Raise them and keep them raised. Raise them and keep them raised. I can see the number is growing. We are at 15. CTL 16. System CTL. Okay, awesome. Thank you. I guess we can continue. You can raise your hands. Thank you so much for that. Thank you so much for that. So you can raise your hand. Let me confirm that you guys can see my screen. Felix, you can raise your hand. Thank you, Amy. Thank you. So, yeah. Yes, so we are going to move on to a short module. This is a short module. It's not as long as the one that we did in the morning, and this one is quite interesting because you'll come across very interesting commands that we have used before, commands that we have used in doing systems administration, and you will use them yourself, especially when you have the likes of, let's say, your Apache server running, and maybe it experiences a problem, and you need to know if it's running or what state it is at. In other words, what state it is at. So this brings us to our next topic, where we're talking about managing services. And as promised, pale kwa group nimewaandikia how to handle the labs. The two different folders that you're supposed to, or directories that you're supposed to create, and I've given you the commands to use. So make sure that you save that one somewhere, copy it to a place where you can access it when you are doing that lab. Yes. Having said that, let's jump on to managing services. So in the morning session, we were talking about programs. I know programs, we've defined what programs are, what processes are. Now we are going to look at services. And our objective for this short tutorial is that by the end of the session, you should be able to explain common commands that are used to manage services on Linux. And then you should also be in a position to explain common commands that are used for monitoring services on Linux. So we have managing services and then monitoring services. So you should be able to describe, or rather even just explain those common commands. Okay, those common commands. So that is important. Let me drag this chart where I can see. Okay, good. So, So one of the commands, and this is the most important command, and I've used it so many times when I was working, and also when I was doing some of my own personal projects, is the systemctl command. Systemctl command. You write it as a single word, systemctl. The following is the syntax of the systemctl command. So you write the systemctl, and then you will have a sub command and the service name. You do systemctl, sub command, and then the service name. So the following are common troubleshooting tasks. The following are common troubleshooting tasks if services aren't working correctly. So you can either restart after any configuration change or restart when troubleshooting. The systemctl command has many subcommands, and those subcommands include status, start, stop, restart, enable, and disable. You can use any of those subcommands. So you can do systemctl start, let's say a service like HTTPD. That's one of the services that you can start. I believe that's an Apache server. So you can do systemctl start, then that particular service like HTTPD. Then To check if this is running, you can now do systemctl, systemctl status, and then the service name. Status has not been added here, but we can also use status. Status tells you what that service is doing, whether it is in a running state, it is disabled, or it is stopped. You'll be able to see that. You understand? You'll be able to see that when you run that particular command. So services provide functionality such as networking, remote administration, and security. That's what Linux services do. That's what Linux services do. So in this example here that you see here, we have run sudo superuser do systemctl status httpd. Then what output are we getting? We are getting this output here. Let me make this one bigger. So the output that we are getting is for our sudo systemctl status httpd, which we ran, our output is this an Apache HTTP server. Okay. It has been loaded, but it is disabled. It is not running. It is disabled. Because it's disabled, what we see here, it is inactive. It's inactive. So the sudo systemctl status httpd commands shows you the service is not started. This service is not started. The HTTPD service is not started. So if you wanted to use that service, then what you need to do, you need to run a start command with systemctl. You see, start subcommand with systemctl. So we have sudo systemctl start httpd, or you can do sudo systemctl enable httpd. So what will that do? It will create a symlink, as in just making sure that the different processes that are supposed to run for that service to run are actually activated on the background. Of course, you'll not see them. And then when you now run sudo systemctl status httpd to query whether this thing is running or not running, you find an output that tells you it is enabled, and therefore the status is active and running. Active and running. So sometimes, because things like Apache HTTPD, Apache server, those are some of the servers that you will use to host your application, or rather to run the processes behind that support your applications or your workloads that are running in the cloud. So if that is what you have, if that's what you have chosen, and then it is not running, then it means that your application will not be running. So what you have to make sure is, you have to make sure that that particular web server or that particular server is running for your workloads to be available, or for your workloads to be able to be accessed. So you will see this a lot when we'll be doing detailed labs later, after we've introduced it to the cloud and the servers, and now you'll start seeing this. Remember, when Joy was taking us through the process of the high-level introduction to EC2, there is some user data that was used when we were trying to provision the EC2 for the first time. So what did we do? When we were doing it, there was that user data, and within the user data, you saw that there was a line of command that was instructing the instance that when it is spinning up, it should run that command for it to do what? For it to provision that server, the Apache server. You understand? So after you have provisioned an Apache server, it's important for you to check whether it is running, whether it is enabled, which means that it will be running, or disabled, which means it's inactive, and it needs either to be enabled or to be started so that it is active and running. That's what I'm getting at. I hope that one makes sense. I hope that one makes sense. 1 second. I hope that one makes sense. Let me see the chat here. Chat. Okay. Good. I guess we are good. So we can continue. Okay. So we can continue. Now that is how you use the systemctl command. It is a very, very important command. So the sudo systemctl start HTTP command starts the service. The sudo systemctl enable HTTP command activates the service so that it is available after restarting the machine. So maybe the service is already started, but now you want it to be activated. So you can also use the enable command. And of course, the status command. We've talked about the status command. That status command is supposed to be used to do what? It's supposed to be used to check whether whether that service is running or inactive. If it's inactive, you'll have to restart it. And then when you check the status again to show you that it is what? That it is active. Sorry, that is active. That's active. So that one makes some good sense. I believe that one makes some good sense. So let us try and run this. I don't have an HTTP server running in my instance, so we are going to use a different command just to simulate what we are talking about. So we say that you run systemctl. When you run it as systemctl status, for example, for SSHD, we know that this one is already running because we are connected to our instance via SSHD. When you run this, what do you get? That's what you get. You know, it shows you that that this daemon SSHD, this daemon, it is loaded and it is enabled, and therefore it is what? It is active and running. You see, enabled, active, and running. So that's what you are able to see. That's what you are able to. So it shows you that this one is okay. This process is running. So you see, again, going back to the same example that we gave, ile example tulikuwa tunasema ati you have these devs, they are telling you that they are unable to SSH into your system, and then you are trying to look at what the problem is. You can run this to see if SSHD as a service is running. So when you run that and then it gives you this and tells you it is active and it is running, then you should know that that is not that's not the problem. Sometimes you get to the root cause of a problem by a process of elimination. You find that this is working, this other one is working, this other one is not working. Then you're now able to reach a conclusion, knowing what is the problem with your system. I hope that one makes sense. So that is how you run that. So systemctl status SSHD. I won't run stop because I don't want to be logged out of my SSH connection. So I won't run that one. But at least for SSHD, that's what you do. That's what you do. So when it comes to managing services, the main command to use is systemctl. You always remember that systemctl, and then it comes with subcommands, as we've just stated here. We've stated some of those subcommands and we've talked about them. Let me just rehash them. Status, start, stop, restart, enable, and disable. All of these are subcommands that can accompany what? Systemctl. I hope that one makes sense. So that is about managing services. Now, when we're looking at monitoring services on Linux, system performance. So there are a number of commands that you can use. One of them is lscpu. This one lists CPU information. lshw lists hardware. du, this one checks file and directory sizes. df displays disk size and free space. fdisk lists and modify partitions on the hard disk. And then we have vmstat, indicates use of virtual memory. Free indicates use of physical memory. Top displays system processes and resource usage. We already saw this. Uptime, it indicates the amount of time that the system has been up, and number of users, and central processing unit CPU wait times. So those are just some of the commands that you get to see. And I want us to experiment with a few of them, or rather demonstrate with a few of them. Let's see. Let's try and demonstrate with a few of them. Here. Sorry. Okay. I'll just have to clear this first so that I create a smaller window. So Control-C stops the terminal from running. Once the terminal has been stopped from running, then you can do clear. That's good. We are back. Then let us do lscpu and see what we are going to get. So there goes list CPU information. So this is supposed to tell us about the CPU. So this is the CPU that we have that has been given to us by AWS. Remember, we are connected to an instance, and that instance has CPU. CPU is one of those resources that have been connected to our instance. So you can see the architecture, all of these are just information extra that anybody that wants to use can use, but I don't think that they are important for our use case at the moment. But at least the very basic, you get to know the architecture. Architecture is like the most important, I think. And then what else is important here that I can see? CPU family, model, thread core, socket, I'm not seeing anything useful for me at the moment here. So that's okay. Then let us also run this other command called df. So df, we clear our screen, we do df. So when you do df, what are we seeing? So df is supposed to display disk size and free space. So disk size, you see our disk has many partitions. Some of these partitions are hidden. And then you can see what is available on each of the partitions. And then you can see usage. And then you can see where they're mounted, the path at where they're mounted, and then what is used of that, what is used. You see, this has been used, of this is available, and that is 1% of use. This has been used. This is a percentage of what has been used. So that is that. I hope that makes sense. So that's how we use the df command. df command. Next, we have the top command. This top command, we used it before, but let me just show you again. You see now, it now gives you the whole picture. The whole picture where you see the number of tasks, what is running, how many are sleeping, how many have been stopped, and how many are zombie, then CPU. Then CPU. So you get to see all of that there in terms of that command. Now, when it comes to monitoring, when you have your workloads running in the cloud and you want to monitor them, AWS has a service that is used for monitoring. AWS has a service that is used for monitoring, and this is just an introduction to it. I'll just mention the service in itself, and then I'll take you also to my console so that I show you how it looks like and how you can access it. But we will do a deep dive later. So AWS CloudWatch is the service that is used to monitor the health and performance of your AWS resources and application. It's called AWS CloudWatch, and that's an examinable question. You'll be asked which of the following services is used by AWS to monitor the health and performance of your AWS resources and application. You'll have A, S3. You'll have B, CloudWatch. You'll have C, CloudTrail. You'll have D, CloudShell. What is the answer? What is the answer? And now I pay answer to say in bado nobody's answering. Let me repeat the question. I'm telling you that this is an examinable question. Good. I had not seen that, Gideon. Thank you. Yes. The answer is CloudWatch. So let me repeat the question for the sake of those who did not catch it the first time. So I'm saying AWS has a service that it uses to help in monitoring the health and performance of your AWS resources and application. And that service is what we call CloudWatch. So in exam, you might meet a question that says, that is framed this way. Which of the following services is used by AWS to monitor the health and performance of your AWS resources and application? Then you have your choices. A, S3, B, CloudWatch, C, CloudTrail, D, CloudShell. And the correct answer, of course, is what? CloudWatch. Yes. So this particular service offers monitoring of Amazon Elastic Compute Cloud, and you'll hear us talk a lot about EC2. We'll not be using the full name like Amazon Elastic Compute Cloud, or when you're talking about S3, we'll not be talking about simple storage service. Instead, we'll just tell you Amazon S3. So when you talk about some of the services that it really helps are things like EC2 instances, where you can see things like CPU usage, disk reads and writes, which are very important, especially if you are doing server management. Then you can create alarms, for example, by saying when CPU usage exceeds a certain threshold, you want to be notified either through SNS. SNS is another service called Simple Notification Service. So it will notify you either through a text or an email telling you, warning, 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 the threshold that you had set has been exceeded. And sometimes this notification that you get from SNS will be channeled to communicate with a different service in AWS. That different service can be something like an auto-scaling rule or an auto-scaling group. What does that do? What it will do, it will spin up another instance because your current instance have been stretched to the limit. So other instances will be created in order to take off the load from this current instance and make sure that your workloads are evenly distributed. So those are the things that we'll be talking to you deeply when we do a deep dive into the likes of EC2 and the related services. But so for now, that will suffice. And as promised, I'll go to my instance, I'll go to my, not instance really, I'll go to my console, and then I'll show you how to access CloudWatch. And I told you, every time you want to access a service, like a search bar, just type CloudWatch. Let's see, and here it is. This is CloudWatch. Click on it. When you click on CloudWatch, give it a second. This is CloudWatch for you. So this is the CloudWatch console. And then now you can see there are a number of things that you can do. Kuna alarms, kuna logs, kuna metrics, you know, all of that, kuna insights. So all of these things can help you to visualize, to see what is running at any given time. My dashboard imenipeleka kwa home because I don't have anything being monitored at the moment. Anything being monitored at the moment. I have an EC2 instance that is running, but now for that EC2 instance, let me go back to it for a minute. For that particular EC2 instance, EC2, there it is. Let it load. So let it load. Okay, there it goes. Then we can go to our running instances. Sorry. Then upper for our running instances, we'll pick Landly. This is the instance that I created. Then I'll go to monitoring, you know, or let me look at status and alarm, see what is here. You see the 3 checks. Then you can shop 3 out of 3 passed. These are they. Systems reachability check passed, instance check passed, and then EBS attached passed. Those are the 3 out of 3 checks that you see here. Then, of course, we can now go to monitoring. So for monitoring, what you see here, this is now part of, this is part of what I can now configure here in my CloudWatch. But now you see here, it is showing me CPU utilization, network in, network out, network packets. You see all of this. There's a way that you can read them, and we will get to it. We'll get to it when you finally go to monitoring. But you can actually see everything concerning the health and the status of your instance right from here. But now you can also direct that these same logs, the logs that are being generated here, to go to what? To go to your CloudWatch. Now CloudWatch will now be able to check your instance and make sure that everything is running well. If, for example, you have that rule that says if it exists this threshold, alert me or create other instances, it will do exactly as commanded or as requested. Na ni vile niliwashow. I told you that this is going to be a very short class. This second class is going to be a short class. So that's all about managing services and monitoring services in Linux. So when it comes to managing, remember we are using systemctl. When it comes to monitoring, we do a lot of, wait a minute. Let me see something. Yeah, when it comes to monitoring, we do a lot of, especially if you are doing it in AWS, we use a lot of CloudWatch. So you will get to know that. And of course, those commands, if you are doing Linux, they are equally important. So you will just go through them and it will sort you. So question here, how might you use the top command when you are troubleshooting? How might you use? Now assume the role of a systems admin and answer this question. How might you use the top command when you are troubleshooting? And why do you restart a service instead of restarting the entire computer? Yes, somebody tell us what you think. If you met this question and you were to answer it, how would you answer it? Somebody? Nikaa mtu anaongea lakini simsikii. Who's talking?
Patrick,
Yes,
it's
Dan.
Daniel. I think you might use the top command to see which processes are consuming more resources and which processes are hanging so that you can free resources. You can restart a service, you can see a service that is maybe having an issue. And one way of troubleshooting is stopping the service and restarting it again to see that it fixes.
Awesome. Very correct. Very correct. That's very good, Dan. That's very good. That is exactly what you use the top command to see the services that are running, to see the status of those services. Just you want to have a high level overview of which services are running, which ones are consuming more CPU spaces. Remember, we were looking at this one is consuming this much, this one is not, this one is doing this. Nice. That's very nice. That's very nice. And again, you can also use it, especially when you first of all want just to view. After you viewed, then the next thing you maybe want to change the priority. You remember what we said about -20 to +19. You want to change the priority so that it does not consume as much resources as it is consuming. That is awesome. Thank you, Dan. That was very good. Then why do you restart a service instead of restarting the entire computer? Mbona usizime tu computer yote na umeamua unaanzisha tu ka service peke yake? Why do you think we do that? Where are the ladies? Bana? Where are the ladies? Dan ame represent for children. So where are the ladies? Girl child, mko wapi? Ni watafute na majina? Natafute na majina? Hata kama uji, just tell us what you think. Tell us what you think. Tell us what you think. Sharon, what do you think? Why would you restart? Why do you restart a service instead of restarting the entire computer? What do you think?
I think it's for efficiency mostly.
Efficiency. Efficiency. Good. Thank you for that. Wacha nitafute another lady. Thank you for that. That is a good answer. Prudence. Why do you think? Why do you think we restart a service instead of restarting the entire computer?
Because when you restart an entire computer, you'll have to utarudi nyuma sana, like utarudi nyuma sana, so it will take much time to restart. But by the time you get back to the system, you'll have wasted a lot of time. Yeah.
Good. Combining your answer and answer, Sharon, those were very good answers. And I see Dan has posted something here that is equally true. We restart a service instead of restarting a whole computer in order to minimize on downtime and disruption. So the most important reason is service availability. Restarting a service, only the application or function handled by that specific service is temporarily unavailable. Other services, databases, and user sessions on the system remain running and unaffected, leading to near zero downtime for everything else. And that's very true because tunasemanga anytime you meet these questions, because these two questions might not feature in your exams, but they might feature in a place like an internet. So ukiulizwa now that you've applied for this system admin role, then you discover that there is this. Actually, they'll not ask you this directly. They will tell you now that you are a system admin working with our organization, then you discover that a service is not running. What will you do? What is the approach that you will take in order to deal with this? So of course, utatumia hizo command, utaonyesha unajua hizo command, kina systemctl status, kuangalia status, alafu kipata iko na shida, you will do start the system, alafu maybe a follow-up question will be, now, why would you not restart the entire system instead of, okay, why not restart the whole entire system instead of just restarting that service? Then this answer about minimizing downtime and disruption will then come up and feature, and then now you'll actually stand out. So some of the answers that we've given is, if the CPU on the server is maximized, you can use the top command to determine what processes might be responsible. That's one of the things. Then number two, a server often hosts many services that users run. Restarting the entire server will mean that the reboot will also stop all the properly running services within the server. Restarting only the failing service means that the healthy services continue to run. So again, that one also speaks to ensuring that you minimize on what? Downtime and disruption. So that one makes very, very good sense. All right, someone unmute and read for us these key takeaways.
Okay. So key takeaways. You use the system CTL command to manage services in Linux. The top command provides a real-time view of processes that are running on the system. DF is the disk-free command that you use to check the available space on a hard drive. You use the DU command to display the amount of space that a file or directory uses.
Awesome. So the DF and DU, those ones you'll tinker with them, you'll try them out, and I believe you might also meet them in your labs. And you can see that one was very short. So remember, we've just talked about monitoring and managing services in Linux. So combined with what we covered in the morning, that is the entirety of Linux management, at least at an introductory level. So let us move on and look at the lab for this session, how it looks like, and see if there is anything that needs to come to my attention before you guys do it. So the lab is on managing services and monitoring. So this is the lab. Let me open it there. Then let me open the KC also. Bash. Okay, so this is in Zakesho. Okay, good. So no worries. That is okay. So let's look at this lab. So let's just look at it. Wanasema anataka nini? So managing services, monitoring. So check status of the HTTPD to ensure that it is running. and that you can make an HTTPD connection, the local host IP address. You will also learn how to monitor your Amazon Linux EC2, use the Linux stop this, using AWS CloudWatch, 30 minutes, that's the time. Now here I can see there is like a small problem, but we will deal with it. HTTP. So we need this one running. Put enter image this. Okay, just a second. Let me see if I can get it here. Command. Okay, use data. Use that data. So let's HTTP. Let's see. So let's try. I'm going to try something. Then I'm going to try it in class because we still have time. I'm going to try it in class so that when you guys go to do it, let me, oh, it's a different lab. Should I start this? Okay, let me just start this one. Start lab. Where is that other lab? I kill it. Kill that. This is for the previous class. Okay, so lab is in creation. Lab has been created. So let's give a field. So for those who are still not very comfortable with creating an instance, this is what you are going to do. So let me create an instance, and then I want to try something different. Not really different. Jay already showed us where we are going to create an instance that has, or let me check here, just a sec, guys. Where is that lab? There is a lab on introduction to EC2. Let me see its instructions, student view. Let me see the instructions that comes with this lab. Yeah, this is what I wanted. You see this one? This is what I wanted. I wanted this user data. So this user data is what I want, and it's what I will use once my lab is ready. Where is my lab? Nimefungua nikaa zote. Yeah, here. So that's what we will use when we are when we are provisioning our instance, so that once the instance is spun up, it will come already fitted with that HTTPD server. So let's give it a few. Wacha tuendelee create. Is Ridge in the class? Ridge ako area? Ridge. Yeah, so the lab is ready. So tunabapa lab iko tayari. So let's check it out. So we go to AWS. So we close this one, yeah. Close that. Then we try again. Second time. So easy too. So let us try and create a new instance. So, okay, so we have one. So we can create a new because I've been trying it, but it's still not working, at least for me. So if you try and then you discover that by a certain lab it doesn't work, just let us know so that we stop creating new instances. So we'll create a new instance, we'll use that, and then our key will create a new key pair, or we'll call it lab. Ngoja kwanza, tumeambiwa tuite aje huku. So labs user will be the name. Give me a sec. Labs user will be the name. Okay. So let me get to this folder. Then we say labs user. Where's the downloads? Downloads. Get rid of this. Okay. Yes. So that's deleted. That's deleted. Okay, it's gone. Good. Then we come here. Now we already have that. So when we are launching, we can now create our instance with that name, labs user. Okay, labs user. Give me a second. Give me a second. So we are going to create it with that name, labs user, and we will use a PPK file, create. So that has been created. Then we will come down for advanced details. Then we will go to this user data and paste the user data that will now create. Just a sec. Yeah, this is what we want. We'll come and paste it here. Okay, good. Then we'll just say create or rather launch an instance. So let's give it a minute for it to do it. Success. Okay, launch instances. Launch your instance, launch your instance. So here we are. So this is the instance that we've just created. So let us wait for it to finish initializing. Okay. Let's wait for it to finish initializing. That's an important point. Let's refresh. Because it has the HTTP key, Might take a bit longer, but tucha tungoje. Let's refresh it again. Still initializing. Let's see. We refresh it again. Still initializing. Let's just wait kidogo. You can see those checks are also initializing here. Okay. So everything else is still initializing. So we wait kidogo. Good. So hapa naonyesha they have all finished. Good. They are there. 3 out of 3. So we go back to our details. We copy our public IPv4 address. Then we come and look for PuTTY. PuTTY. PuTTY, PuTTY. Here's our PuTTY. Let's run it. And we will paste our IP here. Go to connections. Under connections, we will change our TT time to live. Or rather, our keeper lives will change it to 60. You can use that if you want, but I use 16. For SSH, we go to auth, credentials, browse and get our lab user key, labs user key, open that, then we open. Let's see what we get. There we go. Accept. Then you log in as EC2-user. Enter. Authenticated. There we go. We are now properly authenticated. So let us go back to our instructions. So check the status of the HTTPD service. So we are going to check that status, and this is what we will run as our command, sudo systemctl status. So again, I need to find where it is. Where is this thing? It's here. No, it is here. Good. So we run that here. Okay, enter. There you go. You see, it is showing you. It is showing you that the HTTPD service is enabled and it is active and it's running. You know, it's enabled, it's active and it's running. So let us simulate something different. Control C to terminate that. We have just terminated that service. So let us simulate systemctl stop HTTPD dot service. I think ilikuwa dot service ama failed to stop. Okay, let us do this. Let us use sudo and see if that will solve our issue. Yeah, there it goes. So that one must have stopped it. So let us run status again. Systemctl status httpd.service. Let's run. You see, it is showing it is enabled in the system, but it is disabled at the moment and it is inactive or dead. You know, it's inactive or dead. So if we want to restart it, we will run the other command, system CTL, CTL start HTTPD dot service. So we are going to start that service. So when we start the service, again, sorry, I'm supposed to use sudo. Sorry. I believe I'm supposed to use sudo, enter, there it goes. Then now when we do status again, status, enter, there we go. You see it's now running. Runner is now running. Now from inactive to active and running. You understand? It was inactive and dead, but now it is active and running. So that is how you use that command. So don't worry if you've done what I've done by you using the user data and provisioning provisioning the server, the HTTPD server. Don't worry if you don't get this output, because this is supposed to be the output we get from the EC2, or rather from the server that AWS provisioned for us. But that has a problem. So we just have to simulate what we need to simulate, and then we are good. Then once you are done with that, you can then do the likes of top, which will show you what is running. This one you've already done. That one you'll be able to do Bilash Diode. And then on the left side of your dashboard, then select automatic dashboard, then automatic dashboard, let's select EC2. So something like, let's see, on the top right of the AWS button, management console, search for CloudWatch. I've shown you how to search for CloudWatch. And then the EC2 dashboard will open. I've already also shown you these things. I've shown you these ones. So you've seen them. So you will be able to do that Bilash Diode. There is no hurdle in this lab. So the only thing I'm going to add for you for this lab is the user data that I've used. So you'll use that user data. So let me search something here. I copy up. Okay. So let me write it, then I share it with you. Managing services dash monitoring lab. When creating the instance, add this, or Control Z, or managing services dash monitoring, then we say, and creating instance, add this user data, and we come and pick our user data here. Where was it? This one. We use that one. Okay, use that one. Yes. Or the other processes should proceed without a hassle, or should proceed as is. Should proceed as is. So let's see. So where is WhatsApp? Niweke hiyo tu saizi. When it's have AWS restart program. Okay. So I've sent that one to the group. So that should not be a problem. That should be something that you guys are able to do. And in case you run into any hurdle, please reach out to us, either myself, Joy, or even to your peers, and we will be able to help you get to it. So, let me see where are we at. One second. Kwa notes zangu zimenipotelea. No wahala. No problem. Oh, what is that? That's a lab. I don't want the lab. So about managing your processes and managing your services and monitoring your services, at least I believe that you guys have a fairly good introduction to that. You have a fairly good introduction to that. So the other thing that you guys will be doing, just to complete this section, is you'll also be doing a KC on managing services. Now, there is a KC for managing services, and let's just make sure that it's running. Canva imekuwa na drama jana, so yeah, it's running. Which AWS services can customers use to monitor AWS services and resources? This one I've told you. The answer is CloudWatch, sindio? Unajua hiyo. Hiyo nimewaambia. Alafu, which command lists all active services? Someone tell us this. Which command lists all active services? Someone tell us this. Anybody? systemctl status. Systemctl. Let's see. It's either of these two. But I don't think I'm a Neo A, I'm a C. Let's see. Incorrect. So the answer is most definitely the other one. Which command displays the usage of virtual memory? Hii ilikuwa kwa notes, tulipitia tu juu. Which command displays the usage of memory? Fdisk. Are you sure? Not vmstart. Hapo comes ni fdisk. Let's see. No, Habakkuk. Ngoto. Aya. Which command displays the amount of free disk space? Free disk space inayamfai kudunda ilikota baka kwa key takeaways. Free disk space. Free disk space. Somebody? Watamogopa kudunda? Fanyeni hapa mdundi hapa ndo mjue what is the wrong answer and then we'll get the right answer. Which one? Yani, umenyamaza. Free disk space, somebody? Okay. That is correct. Then number 5, which system performance command monitors how much physical memory is available? How much physical memory is available? Which one? Free. Yela anasema tunatumia free. Let's see. Correct. So, tumegonga 60 ni kidogo. We want at least 80 and above. So, the answer here was CloudWatch. Submit. That's correct. The second question. Tulikuwa tumepata hii. You said systemctl and we do that. So the answer is supposed to be systemctl status. Is it? Kuna mtu mwenye kuna answer different? Let's try systemctl status. It's still incorrect. You hata pia mimi nimedunda. So the answer is either the other two. So this is how you drill down the answers, or you can go back to the notes. Notes are also very good. So about my bwana Gail, ngoja hapana. Inio, which command displayed the usage of virtual memory? Hapa tuliambiwa answer ni nini? Virtual memory. Neo free.
D.
E. This one.
Yeah.
Okay, let's go. Correct. Good. Alafu na hapa.
Start, yeah.
Na hapa free disk space. Amount of free disk space, DF, eh?
DF.
Okay.
Yeah, DF.
Good. Good. Alafu na hii ya mwisho Gail alikuwa ametuambia how much physical memory is available, unatumia free. Si ndio? Free. So let's see. Correct. 80%. 80% is not bad, but you can push it to 100 if you want. So though you do your KC, make sure you do your labs. Msiziache zipile. Unaona tayari kwa morning session tuko na labs mbili, tuko na cases mbili. Afternoon session we still have like we still have like the how do you call it? We still have like those other sessions that two other sessions that will also have 2 cases and 2 labs. Umeelewa? Yes. So that is that. So today we are in our morning session exactly at 12. Imepita dakika mbili. You guys, you deserve a break. And then mpumzishe kichwa, grab something to eat. Then let us meet in the afternoon session. Unless kuna mtu akona swali. Is there any question? Any question? Silence means mko poa. So let us meet in the afternoon and continue with our discussion on Linux. So the afternoon session will equally be a bit short. So let us meet in the afternoon so that we can now carry on with the session. Have yourself a good lunch break. See ya.